Hi everyone, I'm going to show you guys how to solve this integral. It's sine x to the power 6 into cos x to the power 5. So I'm going to solve this using this reduction formula. It's sine x to the power m into cos x to the power n. Now I'm going through a book right now. I'm just writing it down. This is the formula, reduction formula. Now I need to prove of how you get this, and then using the reduction formula we can solve the above integral. So that plus m minus 1 over m plus n into the integral of sine m minus 2 x cos x to the power n dot dx. So first of all we need to prove this. So and to do that, let's use the integral of sine x to the power m and cos x to the power n. So I'm gonna break this down like this. I'm gonna write sine x into sine x to the power m minus 1 into cos x to the power n. I'm breaking it down like that. Now I write sine x to the power m minus 1 separately, and sine x into cos x to the power n, I write that separately. Now we're going to use integration by parts. The formula is I equals uv minus v dot du over dx dot dx. Now I'm going to take sine m minus 1 x, sorry, it's sine x to the power m minus 1. I take that as u, and I take dv over dx as sine x cos x to the power n. Okay, so using the formula u into v, first of all let's integrate this to find v. So v equals to the integration of sine x into cos x to the power n. So you can take a substitution of t equals cos x, so then dt over dx equals negative sine x. I'll go on to the next page. So we have dt over sine x, the negative sign, equals to dx. Okay, so we do v equals sine x into, instead of cos x I'm going to write t, so it's t to the power n. Instead of dx I'm going to write dt over sine x, but don't forget the negative sign which I'm going to write in front of the integral. Sine x cancels off, so then v equals to the integration of t to the power n dot dt, and this is t to the power n plus 1 over n plus 1 with your negative sign. Now that's v. Okay, now I'm going to erase all this because it takes too much space. So I'm going to write v equals to negative t to the power n plus 1 over n plus 1. But the thing is, we took the substitution as t equals cos x, right? So this is going to be cos x to the power n, cos x to the power n plus 1. So using your formula, now you can write u into v. So that's before doing that, let's differentiate u. So du over dx equals m minus 1 into sine m minus 2 is the power, and that's what you get. Let me just go through the reduction formula that they got. Okay, So using your formula now, u into v, so it's sine sine x to the power m minus 1 into, so we'll put the negative sign into v, which is cos n plus 1, no, cos x to the power n plus 1, I'm sorry, I'm saying it the other way, over n plus 1 minus v, which is, so we have minus again, minus, so you can write plus cos x to the power n plus 1 over n plus 1 into du over dx, which is m minus 1 into sine x to the power m minus 2 dot dx. Okay, hold on a minute, I think I made a mistake when differentiating u equals sine x to the power m minus 1. Now yeah, m minus 1 comes down and then the power is reduced by 1, okay, it's m minus 2, but we also need to differentiate sine x, right? So that should be cos x, so there has to be an extra cos x here into cos x dot dx. Now we are right. Okay, let's write minus sine x to the power n minus 1 cos x to the power n plus 1 over n plus 1. We can take m minus 1 over n plus 1 out. Now it would be cos x to the power n plus 1 into cos x, so it's going to be 2 into sine x to the power m minus 2. Okay, and now we'll have to break this down into cos x to the power n into cos x to the power 2, right? Now we are breaking it down because you can see in the reduction formula we only have cos x to the power n, so we need to find a way to get rid of cos squared x. So we break it down like that, and cos squared x you can write as 1 minus sine squared x, and then you multiply that with sine x to the power m minus 2, like that, and the expansion would give you cos x to the power n into sine x to the power m minus 2 minus cos x to the power n sine x to the power m. This is what the expansion gives you. So now you can write minus sine m minus 1 into cos n plus 1 x over n plus 1 plus m minus 1 over n plus 1 to the integration of, let's break it down into two separate ones. So cos x to the power n into sine x to the power m minus 2 minus m minus 1 in over n plus 1 into cos x to the power n sine x to the power m. Now this equals to cos x to the power n into sine x to the power m, right? So this whole thing right here equals to this. So you can see we can take this onto the other side, right? You can see they're similar terms, so you can take them onto one side. So you'll have minus sine x to the power n minus 1 into cos x to the power n plus 1 over n plus 1 plus m minus 1 over n plus 1 into the integral of cos x to the power n into sine x to the power m minus 2 dot dx equals 1 plus, we can do it like this, so it would be 1 plus m minus 1 over n plus 1 into the integral of cos x to the power n into sine x to the power m dot dx. Now it might look complex and confusing because of the letters and stuff, but if you guys have any doubts, please drop a comment. Alright, I'll help you guys out. So let's just focus on the right side. Let's solve this fraction over there. So it's gonna be n plus 1 plus m minus 1 over n plus 1, right? You can see the ones cancel off, so we have n plus m over n plus 1. Now this is what we have. We can just take these terms over here below. So let me just, without writing it again, let me just take it down. That, make it a bit smaller. I think I could do that. And drag it down there, just a bit more small. Yeah, like that. Let me make this one smaller too. I hope you all understood. Now, this is what we have. Now all we have to do is just multiply both sides by, basically divide both sides by n plus m over n plus n. So you could write minus sine x to the power m minus 1 into cos x to the power n plus 1 over n plus 1 into n plus 1 over n plus m plus m minus 1 over n plus 1 into n plus 1 over n plus m to the integral of cos x to the power n and sine x to the power m minus 2. These two guys, they cancel off, so therefore you can write cos x to the power n sine x to the power m dx equals to minus 1 over n plus m into sine x to the power m minus 1 and into cos x to the power n plus 1 plus m minus 1 over m plus n into the integral of cos x to the power n into sine x to the power m minus 2. I think this is what they give, right? Yep. So therefore we proved the reduction formula, and that's good. Now let's solve the question. So it's sine x to the power 6 and cos x to the power 5. Okay, meaning m equals 6 and n equals 5. So let's put in the values. So we'll have minus 1 over 6 plus 5 into sine m minus 1 is 5 and cos n plus n, that's 6 plus m minus 1, which is 5 over m plus n, which is 6 plus 5, the integration of cos x to the power 5 sine x to the power 4. So we can go on doing this. So now we need to find cos x to the power 5 and sine x to the power 4. We do the same thing again. Now it's n equals 5 and m equals 4, right? Yep. Okay, do the same thing again. Minus 1 over 6 plus 5 plus 4 sine m minus 1, so that's 3x cos n plus 1, that is 6x. Let me see whether I'm doing it right. Need to recheck all the time. Yeah. Plus m minus 1, so that's 3 over n plus n, which is 9, to the interval of cos. Now n is 5, the same thing, and sine becomes sine x to the power 2, right? You can do it again, and it would be the integration of cos x to the power 5 into sine x to the power 2. So you take n equals 5 and m equals 2. So now it's gonna be negative 1 over 2 plus 5 into sine m minus 1 is 1, so it's just sine x, cos x to the power n plus 1, which is 6x plus cos x to the power 6, and m minus 1 over n plus 1. So m minus 1 is 1 over 5 plus 2, integration of cos x to the power 5 and sine x to the power, now it's m minus 2, 2 minus 2, so it becomes 0, meaning it's just the integration of cos x to the power 5. Now the tricky part in here is we had an interval, right? At the start we had an interval from 0 to pi over 2. The reason I said tricky is now the intervals are from 0 to pi over 2. 0 to pi over 2. Now when you substitute pi over 2 into cos, now you need to put the intervals into all of these. 2, 0 into pi over 2, 0 into pi over 2. You can see you'll get 0 for all of these, because when you substitute pi over 2 into cos, it's 0, and when you substitute 0 into sine, it's 0. So either way you get 0 for all these. This is 0 and this is also 0. All you have to worry about is this integral over there, but we'll have to multiply it with these numbers we have in front, because we had now the integration of, let's say, this cos x to the power 5 into sine x to the power 4. When we take that in, we had 5 over 11 in front, right? So meaning we have to multiply all these terms by 5 over 11. So it's gonna be 3 over 9 into 5 over 11. So it's if you expand the brackets, it's 5 over 11 into 1 over 3. So that's 5 over 33. Now then 5 over 33 comes over here, and then you multiply this by 5 over 33, and this becomes 5 over 33 into 1 over 7. So that is, check, 5 over 33 into 1 over 7. is 5 over 231. So 5 over 231 into the integration of 0 to pi over 2 cos x to the power 5. This is what you need. So now let's integrate that. So you could write that as cos x into cos x into cos x to the power 4, right? And cos x to the power 4, I can write it as cos x to the power 2 in brackets to the power 2, like this. Ignore the intervals for now. So now you can write cos x into 1 minus sine squared x to the power 2. Now you take a substitution of t equals sine x, t equals sine x, dt over dx equals to cos x. Okay, so dt over cos x equals to dx. You go back into your integral, so it's cos x into 1 minus, instead of sine squared x, I'm going to write t squared to the power 2, and instead of dx, I'm going to write dt over cos x. You can see these two cancel off, and the integration of 1 minus t squared to the power 2, you expand the brackets, 1 minus 2t squared plus t to the power 4. This is what you need to integrate, so it's t minus 2t to the power 3 over 3 plus t to the power 5 over 5. Now since we need the value, you don't need to put in the substitution. You can just put the intervals straight away. So if t equals sine x, t equals to sine pi over 2, which is 1, and t equals to sine 0, which is 0. So you can just substitute 0 and 1 into the intervals. So it would be 1 minus 2 over 3 plus 1 over 5. This gives you 8 over 15, meaning 0 to pi over 2 cos x to the power 5 dot dx. This is 8 over 15, and now you need to multiply it with 5 over 231. 5 over 15, sorry, what am I saying, 8 over 15 into 5 over 231. This gives you 8 over 693, and that's the answer. So 0 to pi over 2 integration sine x to the power 6 into cos x to the power 5 dot dx. This equals to 8 over 693. Now the reason that this video is a bit long and the steps are longer is because we need to use the reduction formula to solve this. If you don't have the reduction formula, it would be easier, but it's the question, right? So that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out, and if you guys like my teaching, leave a